So we're getting ready for our summative number 5 in the fall of 2019, and we're looking at a worksheet that is more practice for your summative. So this first set of questions is actually really, really good practice for your summative, with the exception of like this composition or the evaluation questions. These are not on your summative again, so I'm going to skip those, but you're going to do them on your own. Let's talk about domain, though. Remember, there's 2 issues for domain in functions. You have to be wary of having denominators with algebra, or having algebra within an even root. So when they want the domain of function f of x, we have an even root. So in order to determine domain, you have to remember how to set that up in algebra. So whatever's underneath your even root, it can't be negative. So it can be greater than or equal to 0. That's what you set up. And then we're going to solve this. So you're going to add the 3 over, and then when you divide by 5, you get x must be greater than or equal to 3/5. This is something that you guys could confirm on your calculator, but now the trick is you have to write that in interval notation for me, because that's what we're looking for. So the domain could start at 3/5, and then anything greater than it is good. So you do have to set up a little inequality, because it works. And then go ahead and write an interval notation. So h of x. This time you have the issue of you have a denominator with algebra in it. So the rule for our denominators is that they can't equal, denominators can't equal 0. So if you do a quick little solve here, if my denominator can't be 0, that means x can't be 7. And I would like you guys to get fancy with me and write this in interval notation. So negative infinity to 7, and then skip over 7 and go on to infinity. So 2 domain issues to always watch for in PreCalc. Even radicals can't be negative, and then denominators can't be 0. If I have to include everything except for 7, that means everything in the domain is good. So you would start at negative infinity, and then once you hit 7, you don't include it, and then you jump over to the other side of 7 and continue on that side of 7 forever. So I'm making a list of everything that does work rather than the things that don't work. Does that make sense? Okay. This next question says hog. That's composition. If you don't like that notation, which I really don't, I'm going to write it in this nested notation. So be careful. There's another function up here, g. That's g. So when it writes h of g of x, composition of h of g, they want you to start with function h, which is this blue function for me. So 2, but I'm not going to put x in. I'm going to leave that empty for a minute, plus 9. And then we're going to divide it by x minus 7. So everywhere that an x was located originally, I'm supposed to put function g inside of that placement. Now, this is not a good PreCalc answer. We're going to want to simplify this one. So like up here in the numerator, this becomes 2x to the third. And then this is a minus 2, but then later on in the numerator, you have a plus 9. So that would be a plus 7, right? And then down here in the denominator, you'd collect the minus 1 and minus 7 together. So you had x to the third minus 8. So your new function for h of g, you got to set it up and you got to simplify it. You guys can do number 7 on your own. That one's not on the test, but it is something you guys should be able to do getting ready for our upcoming tests. All right. We're about at quarter, by the way. So we're about at midterm. Time flies when you're having fun in PreCalc, I know. Domain and range. We're gonna skip that. That's not on the homework. You're gonna do this for homework. I'm not gonna bother doing this one with you because it's not on the test. This is, however, on the test. So parent function transformations. Your parent function on this example, they want you to use the cubic function. And I would like you to perform 2 transformations. 3 units to the left, and then a reflection over the x-axis. So your parent function, if you shift it first 3 units to the left, where does a left shift occur inside of the function? Left would be horizontal, so it's going to be with the x, right? So what does it look like when you shift 3 units to the left? Very good. So the body of the function, the third power, this needs to be outside of it like this. So make sure that left shift is inside of the body of the function in parentheses. And then when you reflect over the x-axis now, Where does that negative sign show up? If you're reflecting over the x-axis, remember that means a vertical reflection? Outside of the function. Reflection over the x-axis would be a vertical reflection. Yeah, and I get these backwards until I like really stop and think about it. So sometimes I will literally like draw something. So that's that one. There's really nothing more to that one. That was a horizontal with a vertical, so they don't compete against each other. You don't have to worry about order so much. This one, I want you to give me words. We have two non-competing transformations, so let's just start with this one. What would you call this? Be careful. It's in the square root.
So it's a horizontal.
Yes. No. There we go. It is a horizontal compression. So I know. Inside is just messed up.
It's backwards.
It's backwards. Totally opposite of it. Yeah. Okay. Horizontal compression. A lot of kids say of 1/3 because that makes the most sense to them. They would be thirding all of their x values. So I'm with you. I understand that. What about this -4 off to the side of the function like this? That is a down 4 shift. Very good. And again, horizontal with a vertical transformation, they don't compete against each other, so order didn't matter in that one. Oh boy. This question. Okay, I'm not worried about f plus g. I think y'all got this one. Let's talk about f minus g. You'd be surprised how many pre-calc kids can't get f minus g right. So here's f. Here's g. Can you identify where you think maybe someone might make a small but very costly mistake? Yeah, you're right, Taylor. They won't distribute. I mean, not you, because you would always distribute. 3x squared plus 1. And then you're supposed to subtract the entirety of the function 2x minus 3. So, since it's my test, I'm going to write it out properly so I don't mess it up. And I'm going to distribute the negative. And eventually I'm going to get 3x squared minus 2x. What happens to this constant, though? This is a 1 minus negative 3, better known as plus 4. Your final results, this new function, is a polynomial, so the domain has no restrictions on it, negative infinity to infinity. I'm still worried about f times g. This notation is just f times g. Well, what do you have to worry about, pre-calc students, when you multiply a binomial by a binomial? You got, yeah, FOIL or distribute all the way. So just make sure when you're setting it up, you're using parentheses, because you guys, once you see parentheses, you totally know to FOIL it. Can we talk about f divided by g? The setup is not difficult. You write function f in the numerator. You write function g in the denominator. And I don't need you, oops, it's minus, isn't it? I don't need you to simplify this at all, because there's no like terms to collect in the numerator or denominator, so just leave the function itself like this. But now we do have a domain interruption. What's the problem?
X can't be equal to 3 halves.
Yeah, x can't be 3 halves. So for that one, I don't mind if you go like x can't be 3 halves notation. It didn't explicitly say to write domain in interval notation, so I'll accept that. Very good. This will also be on your test tomorrow. So this function, maybe you don't know what it looks like. Sometimes I don't know what it looks like, so I had to cheat and peek at my key, and it looks like this. And you would be graphing it on your calculator. Is that rain? My goodness. It feels very like that's rain. Oh my gosh. Oh, whatever you were trying to get a car wash or something? What? Just like driving in the rain? Oh, okay. Hey guys, this function, because it's x to the negative 2 power, this means x squared gets thrown to the denominator. So does it make sense that you have something really weird happening at x equals 0? Because there's a definite domain interruption at x equals 0. You can't have x equals 0. So that's why you're seeing this vertical asymptote at 0. And now we should be able to answer a whole bunch of these questions. First of all, starting off with, is this continuous?
No.
Yeah, that's a clear no. Clearly not continuous. Domain. Everything except for 0. So let's get fancy. Let's write it in interval notation. So this is how you say everything but 0.
What?
Yeah. Negative infinity to 0. From left to right. So you were thinking range? Were you coming up with a range for me?
Yeah, I came up with a range.
What is range?
Negative infinity to
Yep.
0.
And what kind of a symbol? Very good. Parenthesis on 0 because Daniel says we're not going to hit 0. There's an asymptote there, so you got to use parenthesis. Intercepts. Does this seem to be crossing the x or y intercept or axis? No. Nope, so none. Okay. End behavior. Please don't screw this up again, guys. I need both left and right end behavior, so make sure you give me both of them. So on the left side, what value is your function trying to approach? It's going towards negative infinity, but what height is it trying to approach? 0, yeah. It's trying to get to the axis. It's just not going to get there. And what about on the right side? 0 again. So on what are called rational functions, these guys that have asymptotes, you're going to see them approaching what are called the horizontal asymptote. So in this case, it's at 0. We're going to have a whole section on this coming up a couple weeks from now. Well, yeah, a couple weeks. Increasing. Do you see any increasing roller coaster pieces? And if it bothers you that there's arrows, then just get rid of them for a minute. The second piece is an increasing roller coaster. I'm with you. So from here to here, it's increasing. How do we write that? Only parentheses here. From 0 to forever. I know it increases very slowly eventually, but it's still technically increasing. And then it's decreasing on this other piece, which starts at negative infinity, and then it continues towards 0, but, you know, that's weird. Okay, very good. There's definitely one like this on your test. Now remember, we did one yesterday where like you watched me do one and you were all horrified and mystified by my algebra skills. Yeah, there's nothing that bad on your test, but there is one this bad. So let's talk about how we approach this question. First of all, we have square roots. We have 2 square roots in the problem. I told you the worst case scenario is having them together on one side. The second worst case scenario is having them at all. We can't really get rid of the other one right now, guys, so we have to just deal with it. So let's square. And I'm squaring because these are square roots. I have no doubt that you guys will be amazing at the right side of this equation. You know it's a 5x plus 9. Can we talk about the left side, though? You guys have a 3 plus square root of 2x times another 3 plus square root of 2x. It is a foiling question. All right, go slow, because you saw what happens if you make a mistake here, right? So 3 times 3, that's 9. And then you have 3 square roots of 2x with another 3 square roots of 2x in the middle. So you can write that out, 3 square roots of 2x plus 3 square roots of 2x, or I'm going to take a bit of a shortcut and call it 6 square roots of 2x. And then when you multiply the square root of 2x by another square root of 2x, that's the same thing as squaring a square root of 2x. So you just get 2x. So it's not the worst question we've seen, but I do have bad news for you. You still have a radical, so we're going to have to square again, but not yet. We're going to isolate that radical first. So subtract the 2x over, and then this is kind of nice. You subtract the 9 over, and the 9s are gone. So you have 6 square roots of 2x equals 3x. And this is where you have to kind of make a decision. Some kids like to divide by 6. Some kids don't bother dividing by 6, and they just square both sides right here. Because it's a monomial and it doesn't give me a horrible fraction, I'm going to go ahead and divide by 6. I can deal with a 1/2. So square root of 2x equals 1/2 x. Now let's square again. And this is very, very similar to the one you're going to see on the test. That's what I would call the harder question. So squaring both sides, this becomes just a 2x. But what happens over here? You got to square both the coefficient and the x. So you have 1/4 x squared. Good. Now you do have a quadratic. The good news is it's a really nice quadratic. Let's subtract the 2x over. So 1/4 x squared minus 2x. You can do that factor out the common term kind of factoring. Now a lot of kids freak out on this one because they're like, oh, should I take out a 2, a 1/4, a 4? What do you want me to take out? My answer is just the x. Yeah, don't worry about the coefficients. They'll work themselves out. So inside the parentheses here, you still have a 1/4 x minus a 2. So when you set each of these factors equal to 0, this first one's glorious. You just get x equals 0. And then this next one, when you set it equal to 0, you're going to add the 2, and then you're going to multiply both sides by 4, the reciprocal. So you're going to get x equals 8. And then you're just so happy that you got your answers on the hard question that you're going to box them in and walk away. But you're not done because you still have to do what? Gotta check them. All right. So turns out these both work. So that's nice. Checking is as simple as just plugging them in. So you plug in a 0 here, and you end up with 3 equals the square root of 9, which is 3. Yeah, so check. And then when you plug in an 8, you get 3 plus the square root of 16. So that'd be 3 plus 4, so 7. And then equals square root of 49, which is also 7. So you get an equation that works itself out. So yes, they both check. You still should always go through the effort of checking. Always a good idea, because sometimes your teacher's mean and puts an extraneous one on there. Like here, this one's going to have an extraneous one. I'm not going to finish this question for you though, but we like to have the square root isolated if at all possible. Because that way when we square, we don't have to do any extra weird foiling with the square root. So, you're squaring this, and I heard someone say, oh, we got to foil again. Yep, you got it. So you're going to get a quadratic right here. So you're going to end up with a little note to yourself. You're going to get a quadratic. You're going to have to factor it. Set it equal to 0 and solve them. You're going to get 2 answers, guys. Spoiler alert, one of them is extraneous. You got to figure out who, though, okay? So yeah, I'm going to let you work on that one. Work through that one on your own. All right, matching. Once you guys identify the transformations, you're very good at matching. And this gets you ready for the test coming up, because the questions on the test that are at the bottom of this section, we give you a parent function, an original, and then we give you 3 transformed ones. But then we did that thing where we give you too many options. So like there's 3 graphs, but like 5 transformation options. So it's not a process of elimination necessarily. You got to be careful. Talk to me about h of x plus 14. What transformation is that? How would you describe that to me? When you stick a plus 14 on the end?
Moving up.
Yeah, up 14. And then what about this transformation when you throw a negative inside with the x? Good. Reflection over the y-axis. If you want to call that a horizontal reflection, I gotcha. I know what you mean by that. What about h of x minus 3? In that notation, what does that mean? Yes. Now this next one has 2, so be careful. There's a negative in front. What does that do? Very good. Thank you. And then when you stick a 2 in front of the function as well, very nice, vertical stretch of 2. Now technically those are both vertical things that happen, but they can happen at the same time. They don't like affect one or the other. And then this next one, when I throw a 1/2 in front, what do we call that? Nice job. We're on fire, Taylor. Vertical compression of 1/2. So you're going to be seeing all your heights being shrunk by a factor of half. All right, be careful on this one. There's 2 transformations, and this time it totally matters what order you apply them in. What does this do? Over? Yep. And then you have a plus 20 off to the side. Then up 20. Good. And it would have to occur in that order. So now it's a game of matchy-matchy. Yes, ma'am. Yes. The exception to that would be if there's parentheses that have something outside of it that you could distribute in. You have to do that before you read it left to right. Does that make sense? Okay. All right, so this one, clearly there's a reflection, and it's the vertical kind of reflection, right, over the x-axis. But I also notice that everything is off the axes now, so I feel like it's been shifted up as well. So which one are we matching up to? So it's been shifted up, and there's a reflection over the x-axis. That's F. Very good. All right, this next one thing I notice is your Xintercepts. Here's the original, and here's the new guy. They're not stretched in any way, but they have definitely been shifted over to the right. So who would that be? Yeah, let's see. So I look for pertinent pieces of the problem. Like I look for Xintercepts, I look for, heights, maxes, and mins. It's a worksheet when you walked in.
Oh.
All right, this next one. Again, the Xintercepts, they haven't moved at all, but it does seem to be that it's upside down. So there's a reflection out there, right? Oh, something else happened too, though, huh? So the height on this little max piece was just under 20, and notice where it's at now. It's just under negative 40. So that makes sense when you guys tell me D, because there was also a vertical stretch there. This guy, the Xintercepts don't seem to have moved at all, but I feel like the height is not quite as high as it used to be. That would be E. Very good. Oh boy. That just went up. That's A. Very good. And then everyone gets like stymied by this one. They're like, wait, nothing happened. All right, who's going to impress me with their prior knowledge? It appears that nothing happened, but all of you are going to tell me it's B. Why does it appear that nothing happened when you reflected it over the y-axis? The symmetry! It's an... Oh, what kind of symmetry? I know it's y-axis, but...
Perfectly symmetrical. Folded butterfly.
Is it even or odd?
Even.
Thank you. This is an even function that has y-axis symmetry.
I have literally no idea what you were looking for.
I know, that wasn't very good clues. I'm really bad at, like, whatever that game is. Gestures or whatever. You know.
Charades?
Charades too, yes. But the gestures is like the less involved version of it. And they're always like, what are you trying to say? And I'm like, nothing. What?
You know, you're almost there.
Just keep saying words and you'll get it. Alright, yeah, there we go. Review. Okay, so we're going to skip around on the review a little bit. You got to finish that worksheet for your homework check, okay? The review, a lot of what we just did is on your review, so I'm going to strategically skip over them, hopefully temporarily, but I already have posted a very detailed answer key. So if we skip over something and you're like, I'm not sure what she's looking for, just look at the key. Mrs. Hoffbauer, I believe, was going to post a very full video of her going over these questions prior to this. So maybe check out her post if you want to like watch the whole shebang. A 43-minute rendition of this review. Yep. Alright, so technically we already went over this F plus G, G times H, H minus G. Just be careful. The most common mistake I saw in this last year was kids were pulling the wrong function. Like G times H, and they were multiplying F times G, which is not right. So just be careful you have the right function. Also, remember domain, it does explicitly say interval notation here. So the two things you got to watch out for domain is if you have a square root, the stuff that's under the square root has to be greater than or equal to 0, right? That's one of the domain restriction issues. And then the other issue you're going to have is if you have a fraction, whatever's in the denominator, it can't be equal to 0. So you might have to do a little math to set it up, right? Those are the two issues you're going to run into for domain. So I'm going to skip this problem for now because we just did a couple of them. Yeah, let's talk about, oh yes.
When it's like F divided by G,
Mhm.
there's a radical of negative.
Yes, so that makes, even though the radical normally could be 0, this time it can't. So like, you would do the greater than 0 instead of greater than or equal to 0, and then your interval would be appropriate then.
So
So
you don't have to do that on the denominator.
oh, like, oh,
No.
is there one other review that does that?
Oh,
I won't put it on a test. Oh, rationalize it, yeah. I'm not gonna like, I won't put it on a test. And I can't even tell you like in calculus whether she'll count it right or wrong because I've been told that they don't really care about that anymore. No one cares about radicals. Well, they don't care if they're in the denominator. This is actually a really easy question if you guys know the secret. How do you know if a function is 1-to-1?
I don't remember.
I know. It has to pass a couple of tests.
It has to pass the vertical and
Summative 4 and
line
5.
test.
Alright, it must pass the horizontal and vertical line test. The reason that's called 1-to-1 is because the vertical line test claims it's a function, and the horizontal line test claims its inverse is a function. So as long as it passes both tests, you're a 1-to-1 function. So this time they want you to graph something that would pass both the vertical and horizontal line test.
Can you just put your shirt on?
Uh-huh. Nailed it. Alright, so in the test, I believe we graph you a function, and we're like, is it 1 to 1? And you just write yes or no.
And do we really have to show any work with that?
I don't remember.
Like, can I just draw a vertical and horizontal line?
I don't even think you... Yeah. Oh, it's a multiple choice question. You just gotta circle, like, which one's 1 to 1. You got this. You got this. It could almost be one of these things is not like the other moment, but I think you'll remember. Pass your 2 tests. All right. This question, you got to go back to your Algebra 2 roots. How do you find inverses? You're going to switch the x and y around. So remember, this is secretly a y. So when you switch the x and y around, it becomes x equals, weird negative coefficient, cube root of y minus 1, and then a plus 3 off to the side. So now you get to use your algebra skills. You got to solve for y. So first thing I want to see you do, this one's kind of weird. Don't cube yet. I would subtract the 3 over. You can, we are going to divide by a negative on this next step, so thank you. Because I don't really like this. Well, there's a few things we could do actually. Normally you don't have a -1 coefficient. That's kind of weird, right? If this was like a 3, you guys would come through and divide everything by a 3, right? So just for the sake of habit, let's go ahead and pretend we divided everything by a -1, which is the same thing as multiplying everything by a -1. So on this side, you can write -x plus 3. That kind of bothers me. I'm going to write 3 minus x. Ha! And then here they just cancel. So you have the cube root of y minus 1. Okay, now would be a good moment to cube both sides. And you went with cube because it's a cube root, I assume. And this is where it's good to be a math teacher, because I get to tell you, you don't need to FOIL that, or it's not FOIL anymore. You don't need to expand that out.
Really?
Please don't,
Yay.
because that's nasty. 3 minus x times 3 minus x times 3 minus x is not a small problem. So let's just leave it like that. So right now I have the quantity 3 minus x to the 3rd power equals y minus 1. Last step, add the 1 over. So then I get kids who are like, nailed it. Y equals 3 minus x quantity cubed plus 1. And then they stop there, and then I got to count them wrong. You don't even have the right name. That's not his name. It's G inverse. Right? Wasn't the original G of x? So this guy is called G inverse. So, yes, do all the work, and then come back and give it the right name. Don't forget that part. That one was a little weird. It was like an uncomfortable set of algebra steps, but like, yeah, once you look at it, you're like, yeah, I guess that makes sense. The one on the test is a little more intuitive. You know, the coefficient's not a random -1. Yeah, we're going to have to do B. So, same process. Secretly know that that's a y. So when you go to switch your x and y around, you end up with y minus 5 over 2y plus 3. So I'm going to ask you to solve for y, and we're going to have to go back to our Algebra 2 roots again and remember what happens when you have a problem that looks like this and it says solve for y. We're going to cross multiply this, yep. So this diagonal, you have to do a little distribution. This becomes a 2xy plus 3x. And then the other diagonal is boring. It's just y minus 5. But now you got to think about, okay, in algebra, when I had more than one y in the problem, what did I do? I got to collect them together first. I got to group everything that has a y to one side and anything that doesn't have a y to the opposite side. So most kids just feel like bringing y's to the left feels good. I don't know, it's just some weird thing. Which means the 3x has to go to the right. It's okay. So these are not like terms. So you're just going to write down 2xy minus y. And then these are gone and these are gone. Whoops. Over here, careful though, you have, it is gross, but I really don't care, -5 minus 3x. Remember, it's not your job to make this look pretty. Your job is to get y by itself. So, yeah, you're looking at this going, well, that doesn't help you any because there's 2 y's. So what was the trick we used in algebra? Yes, we could factor out or undistribute the y. So if you factored out a y from that expression, you still have a 2x minus 1. And now you're home free. Solve for y, you just divide. I think you guys did like 400 of these in Algebra 2. Well, kind of this is it. What's the other problem, though, we're going to forget?
Oh, the restriction.
There is a domain restriction, you're right. You don't have to come up with that today, though. The name! Yes, it's not called y. That's not my name. That song's about 20 years old now, right? Like, you don't even know what song I'm talking about. Oh, God. Alright, F inverse. Now, remember, not your job to figure out if this is the best answer or not. This is a great answer. It's my job to figure out if you're equivalent to the answer. Okay? I got this. I have a master's degree in whatever this would be called. Algebraic manipulation. Sounds pointless. Okay.
Have you taken all the math classes?
No, but wouldn't that be fun?
Every single one. What's the last math
Life
class you
goal.
took?
Like official math class? Oh man, I don't know. I think mathematical theory was one of my last ones. But the best math class in college, differential equations.
What?
Everybody take it. It's the best one.
You're lying.
No, I love it. It's just wonderful. The worst math class, cover your ears, internet. The worst math class is Calc 2.
Really?
And 3.
Don't you have to take those to take differential equations?
Yeah. I'll tell you why I don't like Calc 2.
It's hard.
It actually wasn't bad at the end. The beginning of it made me cry a lot, and it was a rough transition. Calc 3 is all three-dimensional figures that you're supposed to graph. I had to graph three-dimensional figures. Yeah. It was not my moment. Okay, this is not on your review. Could you guys sketch something that kind of looks like this? I'll give you some helpful points. This is the ordered pair, 0, -5. This is at the bottom of the front side, I think. Maybe. Is there... Oh, you have one?
Yeah, but it's not that.
Oh.
It's an absolute.
Oh, pretend it looks like this instead.
Are you sure?
Mine's much easier.
That's easy.
Yeah.
Doesn't look easy.
Well, just fine. Do yours then, but mine's easier. Okay, so this is 8, -2. So this is actually a really easy question. It's just like that one-to-one question as long as you remember the trick. The whole point of inverses is that the x's and y's switch. Like, that's the basis of an inverse function. So if I'm trying to graph my inverse to this, I can just take my ordered pairs and switch them. So instead of plotting 0, -5, I'm going to plot -5, 0. And then instead of plotting 4, -3, I'm going to plot -3, 4. And then instead of plotting 8, -2, I'm going to plot -2, 8. And this is where I'm going to have trouble, because now I'm supposed to be able to connect the dots and graph something that actually looks appropriate. So what I do to kind of assist me is I sketch in the line of symmetry for inverses. The line of symmetry is this identity function that goes through the origin. This is the symmetry line. And then I really try, guys. I try to make the graph look good, but it doesn't work. Okay, so remember how there's like their arrow over here? You should see, like if you squint, you should see symmetry along that blue line. Well, good, because I don't. But yours probably looks fabulous, and it'll be just like that on the test, okay? I don't even give you a function. You're just supposed to know to switch the ordered pairs and make it work. Got it? Got it. All right, we did one of these on the last worksheet, so I'm going to skip it for the sake of time. We also did these. Now, can I just point something out to you on this question? I don't think this is on your review anywhere, but what are you going to do when you're solving this equation? Move the 5. So then you have this. It's not on your paper anywhere. It's just on the board. Okay, so it equals 4. Then what are you going to do? Thank you. Oh, I was worried about someone telling me they were going to square both sides.
You can square them both twice.
That's true. That would be weird, but you should take it to the 4th power.
What is that called?
Raising to the 4th power.
Square.
Fourthing it. Fourthing it. Fourth.
But fourth
is not 1/4. Fourth.
But a fourth is 1/4.
Then it would be fourth.
A fourth is not fourth.
Then it would be fourth.
Yes.
So my point is, it's not squared.
A fourth of an inch.
Because, yes, but if you don't put A in front of it and I say fourth something.
Still sounds.
I know, it's confusing. English is a terrible language, isn't it?
It's the word.
So that's why we say raised to the 4th power. Raised to the power of 4. Alright. The point is it's not squared. So you'd be surprised how many people square that. That's not right. So get your bifocals on. You'd also be surprised what people tell me 4 to the 4th power is. Is it 16?
I was going to say that.
No, it's not. It's 256.
Oh.
Yeah.
Which you just type on your calculator.
And
If you don't remember.
128 is half.
Well, that's magical. That was coincidental, though. Alright. We're a little short on time, guys. Can you tell that these are different? The reflection is the problem, right? So, which one has the reflection happen right away?
The first one. Or the second one. Second one.
Reflection right away on this one. When does the reflection happen on this one?
At the end.
At the end. So Piper was asking me earlier about, like, what about distributing it? Like, can I read it left to right? Yeah. You just have to know to do that. You were asking me about, like, left to right. In this case, you can't read left to right until you distribute it. Then you could read it left to right. All right. So how about this one? Can you see the difference? So this is kind of irritating because it's got a horizontal shift and a reflection over the y-axis. Which one has the reflection happen before the shift?
Wait. Second.
The one on the right.
Yeah, this one is a reflection over the y-axis. And then it'll shift left 5. This one, if you leave it like this and you want to read it in this order, you would talk about shifting left 5 and then having a reflection. Okay? A reflection. The plus 10 has nothing to do with the order. Like, it can happen whenever in that graph, but you just have to be careful. If they haven't distributed anything through, that distribution, those parentheses, indicate that that reflection happens afterwards. So just watch out for that. Okay, I got really nervous at first when I was doing this last hour. I thought this was all one question, and I was like, what? It's 2 questions. Okay. So they want you to start with a cubic function. So they're referring to this parent. Okay. So let's talk about what it looks like when you throw a vertical compression of 1/2. Where does that go? Where does it show up? Yes. So there's nothing else with the x right now. So it's okay if you just say like x to the 3rd power for now. All right, then it says down 5. What would that look like? -5. All right, so out of the function, away from the body of the function, -5. And then, careful, reflection across the x-axis now. Parentheses. Very good. Boom. So if the reflection happens at the after everything else, it has to be applied to everybody. So, and I wouldn't bother distributing it and like being like, here's my new answer. I would just stop here. You can distribute it though. All right, this next one. Start with the same parent. But what would it look like if you reflect across the y-axis first? So inside of the body, you have a -x, which, be careful guys, that means you need to put the 3rd power out of the parentheses. Some of you are putting the 3rd power in a weird spot. All right, this is really weird. Now I want you to shift it right 4. So still in the body. So the reflection already occurred. Don't worry about distributing him anywhere. What does right 4 look like? I heard -4. Thank you. And then this body is to the 3rd power. And then up 7 has nothing to do with any of that. So outside +7. Woo! That was good times. I'll be honest, that second one was a little harder for kids to figure out than the first one, so don't panic. Okay, this question was on your last test. you're going to get it right this time. And you're definitely not going to leave it blank. You have a quadratic function. In order to get this one right, you have to know what the transformational form of a quadratic looks like. It looks like this. Remember that guy? Since it's a quadratic, I put quantity squared. If it was cubic, I'd put quantity cubed. If it was square root, I'd put quantity square rooted. It's gonna be quadratic. All right, so now I give you 2 clues. I tell you that your vertex is at -2, -6. So this is your H, and this is your K. And then I give you a random ordered pair of 824. This is an XY ordered pair that you're going to use to determine your A value. So the Y value from that ordered pair is a 24. I don't know A yet. I'm trying to calculate it. The X value was an 8. And then instead of saying minus -2, you guys good if I put a +2? And then instead of saying plus -6, I'm just going to say -6. Okay, how some of you solved for A was curious. Let's not do that again. You're going to add 6 to both sides. So this is a 30 equals A. Now, guys, what is this quantity? Oh. But that's 10, honey. 10 squared. This is a 100. So now we're going to divide both sides by 100. And we're going to get a funky A value, as promised, of 3/10. And now we're going to bring it on home. Come back to your formula. This time, you're going to use your H and K. You're going to use the A you just found. And you're going to forget you ever knew about 8, 24. Not used anymore. So Y equals 3/10. X plus 6. Nope, 2. Thank you. Don't forget quantity squared. And then -6. So that question's coming back at you. Is that the end? Okay, I have a gazillion like match the transformation ones. These are coming from your your remediation bucket over there. Transformations is a sore spot for some kids. So Mrs. Hoffbauer made like 3 different remediation worksheets. One of them is this, where like you're matching this guy 1,000 times. So if you're like, man, I really need to practice that, this is a great worksheet. You can grab it out of the remediation bucket. The key's on the back, so you know if you're right. We don't have a lot of time, so I can't go through anything more. I will be here today after school. Yeah. And I'll be here tomorrow morning before school. And you guys are finishing up your homework, and everyone's turning in something to me. Something. No more zeros. Zeros are sad. All right.